Well, hello everyone. This is Bob in Torrington. I'm in kind of an awkward position. You'll see why here in just a minute, but I've tried to set up my own little studio so that I could give you a demonstration about the project. And I'm in our classroom, actually, believe it or not. So I'm in room 208, the old friendly confines, and I've used some of the physics equipment or the bricks and the poles, some of the things I put together so that I could construct a mechanism so that I could record a video where I demonstrated something, and maybe working at the chalkboard in the future might be a possibility. But I want to show you examples and demonstrate the project for you. I am maintaining my social isolation. I've not seen a human for 4 days now. Just lived out I moved out into the woods and I'm living like a bear in a cave. But so far so good. My first part of the project I'm going to show to you is the Writing Wyoming part that you can see under another tab in our module, the project module. So there's another tab that contains, one of the little links contains the ingredients to do a project called Writing Wyoming. And I'm going to show you the first page of that I think there are 4 or 5 pages in that particular link when you click on it that you could print out. And I'm going to assign this I'm going to do the first couple of letters with you, and I'm going to assign the rest of this for extra credit. So if you want to complete Writing Wyoming and turn that in, you may turn that in for extra credit points. Then I'm going to do my name. I'm going to give you some hints about how you do the project. I think it'll turn out to be a little bit longish, so you shouldn't set out to watch the part about where I write Bob until you're ready to understand and take a little bit of time and listen and those kind of things. So it's probably going to be just doing math for a little bit, so you can save that until you're ready to do something particular on the project. Or what I'm going to demonstrate are 5 or 6 different kinds of functions that you might use when you're doing the project. You'll see the rubric posted as a separate entry, as well as the instructions for completing the project. The instructions, I don't have those right here with me, tell you that the types of functions that you need to include, the details about the project, when it's due, all of that's included in that under the tab that tells you, that describes the project for you. So maybe in a future discussion I could talk about that just a little bit. You can find the instructions. I'm just going to follow them when I start doing my part of the video. So don't want to make this turn out to be too super long, so I'm going to try to get started here. I had everything at this tilty weird angle because I'm about to tip you this way. And you should be able to see my Writing Wyoming project right here. I moved around to the other side where I can write facing straight up. And here were the instructions. The instructions are the same as your project, essentially, that on the graph or a grid that you're going to make using a scale, using a legend that you create to use your own creativity, you'll see in the rubric that creativity is given extra credit or extra points in how your final grade for your project turns out. So I'm going to start following the directions here to graph the word Wyoming using the functions, the families of functions that we were using in class when our semester was so rudely interrupted. So under instructions, say I'm going to write the letters WY here for you, and then we can carry on from that point, or actually I'll switch to my name at that point. But here's how you're going to interpret this all later. The equation that I'm going to graph is the straight line y equals negative 3x plus 12. For the x's, this is the domain of the function, and this is the range. For the x's between 1 and 4, and the y's between 0 and 9. On a grid, this grid is provided inside the package for the Writing Wyoming project. The straight line that starts at or has a y-intercept at 12
and has a slope of -3 looks like this. And what we said, or what the first instruction says, is that we're going to graph this straight line for x's between 1 and 4 and y's from 0 to 9. If you put in x equals 1, you get out y equals 9, and if you put in x equals 4, you get out y equals 0. So that piece of the line, when I show it on the graph, looks like from x equals 1 to, and at the point, I guess I'll say at the point 1, 9 to the point 4, 0. So that straight line and that domain and range give a piece of straight line that, oops, and I didn't have my ruler right handy here, so I'm just going to connect those dots later. But that actually, let me connect them now. Apologize for having a piece of equipment that was out of place here. So here's my ruler, and here's my piece of my straight, non-horizontal, non-vertical line. You'll see the different requirements of the project are 20 different functions to write your name or your initials. Talk about that a little bit more as we kind of go on. But that first instruction gives me that little piece of the word Wyoming. The second instruction says that I'm going to graph -6 times the absolute value of x minus 5 plus 6 for the x's between 4 and 6 and 0 and 6. And you'll be figuring this out for your project as you go. But here's what that did. Maybe I'll point at this as I say it. I've shifted the absolute value function 5 units to the right and up 6, and I'm growing at a rate. This negative sign, remember, reflects the function, and I'm going to make it grow 6 times faster than the regular absolute value. So at the point 5, 6 is right here. The function, instead of growing over 1 and down 1, will grow over 1 and down 6. So the absolute value function graphed over that range of x's and y's gives you this part of the word Wyoming. So my x's, remember, went from, I'll show you, went from 4 to 6. My y's went from 0 to 6. So my two pieces, the graph of -6 times absolute value of x minus 5 plus 6 looks like this piece for the x's from 4 to 6 and the y's from 0 to 6 as well. So I don't want to get out of kilter here. I can't really see what I'm doing. So there I just did instruction B. And if I was doing this for my project, I would label this somehow, or I might do it in a different color, or I might do something to let be known. You'll see when I show you the other papers here in a minute that there's a place where you can list what letter that you're working on or what piece of the function. So you make some legend to show which particular part of the function that you're describing. For the second part of this function, or the last part of the letter W, here's the straight line that makes that graph. Y equals 3x minus 18 for x's from 6 to 9 and y's from 0 to 9. If you put in x equals 6 into this function, 3 times 6 is 0. So add x equals 6, you're at y equals 0. Add x equals 9, you're at 3 times 9 minus 18 is 9. So you're at the point 9, 9. So those instructions give this piece of the line, the domain and the range for the pieces of the line from 6 to 9 and 9, 9. I was trying to make marks here so I could see what I was doing. And hopefully you can see what I'm doing. I'll keep trying to check that I'm in the right viewing window here. But there's those three instructions: the straight line with a negative slope, the piece of the absolute value, and the straight line with the positive slope. Those first three instructions spelled the letter W. Instruction D is a parabola shifted right 12 and up 3, so that's where the vertex would be, growing at the rate of 1 to 1 and 2 to 4, like a regular unstretched parabola. And we're going to sketch that in for x's between 10 and 14. One thing that I'll suggest as I'm doing this project all the way through is that you substitute some numbers in, sometimes into your functions, to make sure that you're getting the values that you want. I'll do this mentally. If I put 10 into this function, 10 minus 12 is 2, squared is 4, plus 3 is 7. So I'll be at the point 10, 7, and when I put in the number 14, I will get out the number 7 as well. So the vertex is at 12, 3, and here I'll stick that on the graph. There's 12, 3, and an unstretched parabola over that range and domain, 1, 2, 3, up to 7, and 7 on this side, symmetric, and that instruction gave this little chunk of parabola. Sorry for my scribbling there, but this is for demonstration purposes, not to turn in for a grade. Like I would work a little bit harder at making a nice picture by the end. The last instruction is I'm going to graph x equals 12 for just the number x equals 12. I'm going to make a vertical line at x equals 12 over the range 0 to 3. So from 0 to 3 at x equals 12, there's that vertical line that makes the bottom of the letter y. So in those 5 instructions right there, I wrote the letters W and Y. You may complete this. I'm going to work on another graph from the start, my name, and show you how I would come up with some different kinds of those requirements for the function starting here in a second. But that 5 instructions got me those 3 letters. I'd imagine it's about only maybe 6 or 7 more steps, and you could have Wyoming. There's several different possibilities for straight lines, vertical lines, absolute values. Our whole family of functions are in play and actually required, as you'll see in the project as we kind of carry on. All right, so generally speaking, our project looks like this one, that we're going to make a drawing of our name. You may use initials. You have a 3-character minimum for the letters that you write of your name. You can write a nickname. You can write a, I don't know, there's a lot of things that are acceptable, but generally speaking, they should be different than somebody else's name. So that's the main priority. And then you can also include a design. So if you don't use up all 20 functions that you're supposed to write for this project, then you can use some of those that are left over, some of the ones that you have, and make a design after you've written your 3 initials minimum. I've seen a lot of creative things done in this project where a student wrote their name in cursive or in some different kinds of letters to make, block letters versus kind of curvy letters. So there's a lot of different ways that you can approach meeting these requirements. But you'll see here on this sheet is included in your project that there's a minimum of 20 functions that you have to include, and there's minimum requirements of at least 1 parabola, for example, and at least 1 circle, at least 1 cube or cube root function. And I'm going to demonstrate doing some of those to write my name. As you read the instructions for the project, when you see it published in your Canvas page, the requirements are that you number each function, you give some sort of a legend that is able, that somebody that's trying to read your project can follow which function belongs to which letter that you're writing. And there's a further requirement that all of your integer, or all of the constant values that you use are rational numbers. So you'll see that on your page, and that's not written on here. The due date for your project is May 1st. You'll see that on the paper. I don't know if everybody has access to a printer of some kind, but you'll see on the project that the due date is May 1st. So I made a grid, and I'm going to write the name Bob on here. I'm going to show you how, using some of the different functions requirements that were requested in the project that I showed you a second ago. I've already kind of prepared this sheet is part of the Writing Wyoming project, and I'm going to use it to kind of demonstrate how I wrote my name. I thought about this a little bit before I turned on the video, and I'm going to write capital letter B using 5 functions. I'm going to make a circle to write the letter O in the middle, and I'm going to use 2 functions to write the lowercase b at the end. So that would have given me a total of 8 functions if I was doing this for whatever, and then I would have some other 10 more functions, 12 more functions required, and I could draw a design. I might, if I was doing this over again, I might write Robert, and that would take 6 letters, and that might use up all 20 functions. So there's some different, as you think about using 20 functions, there's some different choices you might make. I would say the thinking about the project probably should begin probably a little way before you start trying to do it. So I kind of at first thought about writing B-O-B, and I thought to myself, well, you know, there's a lot of roundness, a lot of curvy letters in the name B-O-B, and so I thought I would make my scale at the beginning from 0 to 8 in the Y direction, because stretching by factors of 2 when you're talking about roundness. But as you saw on the Writing Wyoming project a second ago, that scale was up to 9, and so there's some different choices you might make depending on how you think about it to begin. So my job is going to be to write the name Bob, and I'm going to talk using my pencil right here through the process of creating the first function and putting it onto my graph here below in just a second. All right, so here's my ready, set, begin. I'm going to write the straight vertical line for the back side or the left side of the word for the letter B. So I'm about to make a vertical line, and as I make the vertical line, the domain, maybe if you saw what I did on the example for the Wyoming just a second ago, a vertical line has a domain of just a single number. So the only input, the value that you put in, so this is going to be the domain of my function, and I'm going to make my letters of the word B-O-B be 8 units high. So the domain for that piece of the function, and I could, this part, as opposed to having to talk much about it, I could just fill in the sheet that I would turn in at the end along with my project. So the equation is going to be x equals 1, and the domain is going to be the domain is just the number 1, and I'm going to make my letters 8 units tall. So my range I'm going to make from 0 to 8. All right, so there's the first part of my letter B. Here's the graph that I am going to do it on, and I think I'll do it while I'm constructing it. I think I'll go ahead and perform it. So here's the straight line from 0 to 8 at x equals 1. I made a code, I called this B1, so maybe I might put a little 1 by it depending on when I turn my final example in. So I might color code it, I might do something to make sure that everybody understood what that was. That seems pretty straightforward as we go. All right, well, now to make things a little bit more relevant to you guys, you saw all of those requirements. I decided that when I was sketching out a possible example, and I probably would work on this part a little bit first, that I would make my letters be, since I was thinking of all the roundness, I would make them be 4 units wide, and that therefore meant when I was going to make this letter B, I wanted to go in 2 pieces. I'm going to make it into 2 functions so I can give you examples of more things. I'm going to go over 4 and down 2. So the 0.56, so I never did finish my example here. So next, to make in my letter B, I'm going to make this part, and so I'm going to go from the point 1, 8 to the 0.56, and I decided to pick some kind of a function that I don't know, my B is going to end up looking a little pointy because I'm going to switch functions in the middle. There is the possibility of using a sideways parabola that I guess you could take advantage of if I wanted to make it rounder. But I'm going to go from here to here using a quadratic function. So I'm going to go using a quadratic. Okay, which means that my basic model that I'm going to follow is y equals x squared. And notice on the picture, I decided I was going to make it be from 1/8 to 5/6, that it was going to be kind of flattened out just a little bit. So the things, remember, that you're allowed to do to any of our functions are to multiply them by a constant, to shift them some distance to the right or left, and to move them some units right up or down. All right, so what I think I'm going to do in this particular case, and you might do some things, you can adjust these constants to make the fit through the points that you're talking about. But what I'm going to do is I'm going to put the vertex of my parabola at the point 1/8. So I'm going to put the vertex here, and then adjust the stretching factor so that as I grow over 4, I'm going to go down 2, like I want it to do. So I want to go right 4 and down 2. So here's my thought process then. My function in the next thinking step would be a times x minus 1 plus 8. And that gets the vertex to be at the point 1/8. Right? There's going to be a negative in front of this number that I put in the front to make it grow downwards as I go. Now I'm going to think about the growth rate that I want, the constant that I'm going to put here, to make it grow at the rate that I want to. So normally, the normal growth rate of a quadratic of x squared is right, and it wouldn't matter if I was going right or left, so excuse me, I kind of scribbled the word right there, is right 4 and down 16. Now I said down, that's because I was thinking in my mind about having it grow as a reflected parabola. So normally, right 4 and down 4 squared. All right, but I only want it to go down 2. So I want it to go down 2 units. So my multiplying factor would be 1/8. The normal growth rate is 16. I only want it to grow 2, so I want my parabola to grow 1/8 as fast as the normal unstretched parabola. I'm going to go ahead and put the minus sign in front of the negative 1/8 to reflect it and make it grow downward. And I think I've constructed function number 2 on my chart, and I'll go back to the chart and do it in just a second. But I think my function is going to be y equals minus 1/8. So I'll say I think I'm still at the thinking stage until I check something. So in the privacy of my own home, I would check my function and make sure that it worked. But here I just put those thoughts together that I did as I was talking along. My growth factor is 1/8. My vertex is at 1/8. And now I think about maybe substituting in, here I'll put it over to the side. How about if I tested x equals 5? So to make sure that it's working the way that I want. If we were in class, I would probably do this out loud by just looking at it, but here I'll substitute in 5 minus 1 squared plus 8. And maybe talk through this part. If I substitute in 5 minus 4, or 5 minus 1 is 4, squared is 16. 16 times 1/8, or negative 1/8, is negative 2. Negative 2 plus 8 is equal to 6. So the value that I wanted to get out when I put in x equals 5, I want the parabola to be at the value y equals 6. So there's my second function. I'll back up now to my project here, and I'll put those, I already put it on the graph, but now I'll put it into my answer key. So my function is f of x equals negative 1/8 times x minus 1 squared plus 8. And that goes for, here on the picture, that goes for x's from 1 to 5 and for y's between 6 and 8. So the values of that function that I want to display on my project are x's from 1 to 5 and y's from 6 to 8. there. I did function number 2. I did a quadratic. I could check that off of my list and move on to the next one, which I think I will. So my next thought is maybe I'll try a cubic. So back to my thinking paper here. I'm going to try a cubic function for this piece of that letter. So here I am demonstrating on my B. So for this part of the B that goes from the point 4, 1, 4 to 5, 6. So I'm going to put a cubic function in this part right here. So my B is a little bit pointy, but I'm doing to demonstrate some different functions. If I wanted to make it another quadratic, that might have made it look rounder, or I could have done the other half of the quadratic that I put. Anyway, so I'm going to do this part of that B using a cubic. So my basic function, y equals x third, the same things that I did before to it, I'm going to do to x to the third. So here's the step maybe I would have you think about first. Let me shift it to the point 1, 4. So there I've moved the cubic function to the point 1, 4. And again, another simple example of just adjusting this growth rate constant to make the parabola go from 1, 4 to 5, 6. So I want to go to the point 5, 6. All right, so here's a way that I would suggest it. How about solving the equation? So y is equal to A. I'm going to try to figure out what that number is so that my cubic grows at that rate instead of the normal cubic growing rate. And I'm going to substitute in the number 5 for x. And I could talk about the normal growth rate of the cubic function as you go over 4 units. That number is 81. So if as x goes 4 units away from that center point 0, 0 on x to the third, the function grows by 3 to the 4th power, which is 81. So the normal growth rate is 81, and I might have talked about it that way, but I'm going to show you how you can solve it as an equation. So I want to put x equals 5 in and get out y equals 6. So I substituted that ordered pair into my example here, put x equals 5 and y equals 6, and now I'm going to solve for the number a. 4 to the third plus 4 equals 6. Subtract 2, a times 81 equals 2, and divide by 81. So there's the factor a that I want to multiply my cubic by to make it grow up by 2 units as x goes over 4. As I increase x by 4, I only want to increase y by 2. So here is that part put together, and then I'll put it on the function page. So part number 3 of my graph, y is equal to, or I should call it f of x maybe. F of x is equal to 2/81 of x minus 1 to the third plus 4. Right, and I tested x equals 5 to make sure that that worked. If you put in x equals 1, that makes this part be 0, and you're at the point 4. So there's the function that will get me this piece of my graph from 1, 4 to 5, 6. And on the paper where I'm kind of keeping track of my final turn-in paper as well, part of my results, I put f of x is 2/81 of x minus 1 cubed plus 4. So there I did a quadratic and a cubic to kind of connect the dots on my B. Next I decided to do something super